The views expressed on Skeptically Speaking do not necessarily reflect the opinions of the University of Alberta, the Students' Union, our affiliate stations, or CJSR.
Hello there, and welcome to Skeptically Speaking. I'm your host, Desiree Schell. So in the last few weeks, the genome has been all over the news. From pine beetle DNA research to the sea lamprey, which, in addition to being the scariest looking thing I've ever seen, remodels its own genome. But what's really interesting is the human genome. We're heading into what previously could only be done in science fiction novels. So we need someone to help us separate the reality from the fantasy. A guide through the genetic jungle to lead us through the legislative labyrinth. A Sherpa through the mountains of moral ambiguity. I think I've made my point. Today's episode features Fintan Steele, Director of Science Education and Communication at the Broad Institute, and he'll be with us a little later in the show. But we'll start out with some interactive skepticism. We have Marion Kilgour in the studio, who's a mechanical engineer and member of the Edmonton Skeptics.
Hello.
Thanks for being here, Marion.
No problem. So my topic today is Canadian skeptical projects that anyone can get involved in. There are a lot of people, we go to the skeptics in the pub, we meet a few skeptics in our small town, or you're in a really small town and you're the only skeptic there, and you're not really sure how to get involved without going crazy. So, the 3 Canadian-run projects I have for you are underway or getting up and running, and are always looking for people to help out and get involved. So the first one is a podcast called the Skeptographers. You may have noticed that most of the podcasts in the skeptical community are small groups of people with not a lot of week-to-week listener input, which is good because they can go through and they can pick out what they want to do. But the Skeptographers is looking to get people a little more directly involved in whatever they're interested in. The people who want to do podcasting but don't have enough stuff to go through and do a full podcast on their own.
Or enough time.
Or enough time. That's the other thing. We're trying to cut down on the individual time involved and just get more people. So, this one's organized by the Edmonton Skeptics. So we'll be putting the segments together, but anyone can submit segments from anywhere in the world. And if you don't like writing, if you like writing but don't like the sound of your own voice, we'll find somebody to record them for you. That's not a problem either. So that's one. Number 2 is a skeptical blog for Canadians that's starting up. It's going to be a group blog called Skeptic North. It's planning to start October 1st. And, there were a lot of Canadians at the amazing meeting, and we were thinking, how can we get more Canadian skepticism out there, since a lot of what we have comes from South? And this was one of them. So we're getting a lot of, prominent bloggers, some Canadian skeptic, Science-Based Pharmacy, he was on the show a couple weeks ago, and anyone else who's Canadian and interested in blogging occasionally. So we'll have contact links for those up on the Skeptically Speaking website for both the Skeptic North blog and the Skeptographers podcast. And third, of course, is Skeptically Speaking, because Desiree is always looking for input. So
Glutton for punishment, really.
Yeah, well, So if you want to email her, questions for the show would be good. Or if you want to call in, because that's good practice, too, for anything. Arguing, listening, helping people out.
Okay, so the Skeptographers, what kind of topics have they done so far?
So far, we have done everything from whether or not adding salt to your pasta water makes it boil faster to an interview with P.Z. Myers. So pretty much the entire gamut of whatever you think people should be critically thinking about.
And this project actually debuted at the Amazing Meeting this year.
Indeed. We put out our pilot episode at TAM 7, and we have episode 2 up and ready to go. We're just sorting out a couple things before we put it up on the website.
Okay, so what's the distribution schedule? Or has it been planned at this point?
We're waiting to see how many people we can get involved. Ideally, we would have a 20-minute podcast every 2 weeks. So we've got a buffer of material. We just need to get it moving, which is where all of the skeptical listeners come in.
Great. So what happens when someone submits a piece and maybe it needs some work?
Well, when somebody submits a piece, other users, they can comment. It can be flagged for if it's quality issues or something like that, and it has to be voted on. So if it's something that is completely out to whack and not skeptical at all, then ideally it will get no votes. And at the end of the day, I mean, the production Edmonton Skeptics, if it's really out to lunch and somehow got through the voting system, it would probably just sit there and not end up in a podcast. But if it comes down to it and it needs editing and revision, you can upload new revisions based on comments people give. That's not an issue.
Okay, and you do communicate with the people that submit, so you'll give them feedback, and if it's not quite up to snuff, they can try as many times as is necessary.
Oh, yes. There's no limit. It doesn't have to be perfect the first time. That's not a problem.
Okay. So the blog project that you mentioned, that's still in its formative period.
Right. Right now, there's a list of interested people, or interested bloggers, and we're looking for new people, and the website design and the actual how they want to distribute the blogging and that sort of thing is just getting hashed out. There's a Google group. One of the other discussions on the Google group is what Canadian skeptical groups could do to sort of unite and have a stronger voice. But the first step towards that is this Canadian blog.
Mm-hmm. And if you do want to know more about that, please do go to the Google group. It will be posted after this show. And I'm on that group. And some of the things that I actually find interesting is people somebody posted a link to something that happened in Edmonton that I actually didn't notice, and somebody in Toronto caught it. So there's a lot of interesting news on that group, and there's a lot of just ways to interact with your fellow Canadian skeptics, because although there are a lot of us, we're not very public. So this is a good place to go.
And we're quite a bit spread out.
So thank you for the Speaking Up plug.
No problem.
How does it feel to talk on live radio? For anybody that's scared to call to do a Speaking Up episode?
It's not too bad. It's kind of forgiving. Des is sitting over here smiling at me. She's very polite.
I'm Canadian, don't you know?
It's not that scary for anyone who wants to try it. And you know what? The people listening to Skeptically Speaking aren't about to email you if you goof up and go like, I can't believe you did that. They understand.
And again, this is really good practice for anybody out there who is part of a local skeptics group and is planning on doing any media work in the future. This is a very good opportunity for you to call and just fumble through this. You're allowed to fumble. So the website addresses again will be on our website after the show. And unless you have anything else, I think we're done with you, Marion.
Oh, I'm so hurt, Des. Go on, interview your genetics guy.
Thank you very much. And as Marion said, this stuff is good for you. So if you want to do what she just did, send an email off to feedback@skepticallyspeaking.com with Speaking Up in the subject line. Just give us a brief idea of what you'd like to talk about, and we'll get back to you. So next up is Fintan Steele, and we'll be talking about genomics right after this.
Skeptically Speaking wants you to question everything. To be part of the discussion, call in every Friday from 6 to 7 Mountain Time at 780-492-2577, extension 1. That's 780-492-2577, extension 1. You can also email your questions and comments before or during the show to live@skepticallyspeaking.com, or if you're on Twitter, @skepticalradio. After the show, continue the conversation on our website at skepticallyspeaking.com, or check out our Facebook group. You can also subscribe to our podcast on iTunes, and while you're there, why not add a review of the show? Skeptically Speaking also airs on Citywide LP 99.1 FM in Madison, Wisconsin, Public Reality Radio, WPRR 1680 AM in Grand Rapids, Michigan, Roslyn 101.1 in Roslyn, British Columbia, and on freethoughtradio.com. And now, back to the show.
Welcome back to Skeptically Speaking, and I'm your host, Desiree Schell. Today we're talking about genomics with Fintan Steele. And usually I summarize our guests' bios, but honestly his is too perfect to paraphrase. Fintan currently works at the Broad Institute of MIT and Harvard, a new cross-institutional research powerhouse aimed at bringing genomic science into medical practice. As Director of Science Education and Communication, his job is to figure out how to tell people what the heck this means and to minimize their fright at the prospect. In addition to a doctorate in genetics, Steele also haunted the halls of academia long enough to gain a master's degree in both medical ethics and theology. He obtained the theology degree while he was a member of the Benedictine Archabbey of St. Meingrad, where he was ordained as a Catholic priest. He left the priesthood and the monastery after realizing that there was a substantial gulf in his experience between beauty and truth. Steele has written about theology and genetics in both scientific and non-scientific venues, and he's currently working on a book about the science and theology of intelligent design, or rather, about why intelligent design contains neither. He lives with his legal in Massachusetts husband, Scott Beard, and 3 rescued Cornish Rex cats in Medford, Massachusetts, the home of Jingle Bells and Amelia Earhart. Fintan, that is the best bio ever. Thanks for being here. So, I just realized that last episode we had a sheep herder turned Skeptical magazine editor, and this time we have a priest turned geneticist. I love this show. Did you want to tell us at all how you sort of came to that career change?
Well, Mendel was, of course, an Augustinian monk. So I don't claim to be in the same league by any means, but he actually destroyed data he wasn't interested in or didn't make sense.
Really?
But I was raised in a small town in the Midwest, conservative Catholic. I knew I didn't like girls. I couldn't figure out what that meant. I thought, I'm supposed to be a priest, which, nothing like going to an all-male establishment to figure out that whole realm of life. But it was an amazing experience, 8 years in a Benedictine abbey. It's really a beautiful kind of, usually transcendent kind of thing, and I got fascinated with the biology of transcendence more than necessarily the theology of it, and realized that I didn't really believe any of it, but it was still an amazing experience, and actually made the study of genetics, which was my first love. I did undergraduate in pre-med. Made the study of genetics actually a lot easier in some ways, because I was more open to ideas and complexity than many people that come up through science.
Right.
Sorry, I have a bit of a cold, so I hope I'm not hacking away too bad here.
I appreciate that. Thank you. So, as humans, we think that we're very, very special. And before the show, someone actually mentioned to me that chickpeas have more DNA than I do. And that, it made me feel a bit smaller, really. So what does that mean, that it has more DNA than I do?
It's just a different way of trying to wend one's way through life. So, humans, the odd thing about, there's several odd things about humanity from a genetic point of view. One is this whole emergence of self-reflexive consciousness, this kind of awareness of self and mortality and all that, and the kind of growth of forebrains and the number of genes that are dedicated to that. And I've actually seen people argue that that's actually an evolutionary mistake that will hopefully correct itself one of these days, which is a pretty horrible way of looking at life. But humans are just part of this kind of, there's no up or down in evolution. It's totally open playing field, biology trying to find niches in which to grow, and playing with genes and alterations to try new combinations and new things. And humans have a specific kind of history of evolution, but it hasn't been a teleological evolution. It's not that things are aiming towards humans.
Right.
Teilhard de Chardin writes so beautifully, but so entirely wrongly about the forward progress of evolution. There's no forward progress. It's all lateral movement and branching. And when you stop to think that 99.7 or 8% of the species that have ever existed are no longer here, we're just kind of at a weird little privileged moment in time for our species. Like I said, it's not entirely clear that our species is going to actually survive evolutionary winnowing once we try to remove ourselves from those kind of evolutionary pressures.
Well,
does that make sense?
Yes. Well, okay, that being said, so who has a better chance evolutionarily, the chickpea or me?
A better chance of what?
Continuing on with the evolutionary process.
Chickpeas actually have more because they have more stuff to play with. We actually have an interesting paper coming out. I'm not breaking embargo here. I'll just tell people about it. In the September 9th paper issue of Nature about the potato blight genome, which sounds neither usually exciting unless you're Irish or all that meaningful. But it turns out that particular fungus is dealing with its, or it's an oomyosite to be proper, it is dealing with its evolutionary forward-looking by having this massively huge genome, about half of which or a little more is nothing but kind of a gene reshuffling factory where it's got bits and pieces of all kinds of DNA that it brings into each generation, reshuffles in different ways to try to overcome the host resistance, which is part of why we're seeing this amazing outbreak here in the northeast of the United States and northwest or southeast of Canada. It's an amazingly cool and kind of creepy critter, and how it's doing it. It's just a different way of genetically approaching one's survival.
If anyone wants to get into this conversation, the number to get on air with us is 780-492-2577, extension 1, or you can email us at live@skepticallyspeaking.com. We're also on Twitter at Skeptical Radio. Okay, so you're talking about research. Actually, there's been, honestly, a ton of research in the last couple of weeks. I'm just wondering if you wanted to talk about some of that. For example, the scientist that actually decoded the entire genetic structure of HIV.
Yeah. So, well, let me start with why this is all starting to happen so quickly. Mm-hmm. The cost of sequencing has just been tremendous in the past. The human genome was billions of dollars in 10 years. A year from now, we think it's probably going to be about $10,000 and a couple weeks maximum. And a year after that, it might be as cheap as $500 and half a day, because the technology is dramatically advancing on the front of sequencing. Lots of very clever techniques to read a bunch of 4 letters over and over again.
Right.
But the other huge technological breakthrough, of course, is computational ability. Just the massive amount of data that are being generated, and the ability to be able to lay it out in an intelligent way on a bunch of different servers and be able to access it and analyze it. So these two things that kind of come together, the kind of wet lab and the in silico lab, to really explode this field. And so as a result, there's an awful lot of raw sequencing going on, and not just human genomes, but a bunch of mammals, pretty much everything. There's a huge program that we're involved with, the microbiome project, trying to analyze every critter that lives on or in a using some people that volunteer to have samples taken, and I won't go into the gory details of all that.
Oh, no, we're getting into that later, definitely.
Oh, good, yeah. I have pictures. No. And I want to put it in the correct context. I mean, the genetics, and people tend to miss this, genetics is just a recipe. If I baked a cake in Banff or in Boston following the exact same recipe, the cake is going to turn out different. The ingredients might be similar, but all the environmental stuff that goes into it, altitude and temperature and everything, it all affects how it comes out. So getting a readout of the genetics helps inform us about how the biology works, the kind of wear and tear and grind of the everyday is the stuff that counts. And that's a lot more complex than genetics, and just beginning to make inroads there.
Well,
but it is exciting.
Sorry, go ahead.
No, but it is exciting because we're actually beginning to understand how all these kind of cell circuits work and the basic pathways. If you think about it, humans have about 20,000 genes, more or less, and they're regulated in various ways. But all of them kind of come together. The proteins they encode or the regulatory things they encode come together around a couple hundred cellular pathways, all of which are highly interactive. And it's complex, but it's not infinitely complex. We can begin to wrap our arms around it. And then you begin to really understand how does cellular life work and what goes wrong in diseases, and how do you really think about fixing them and not just treating symptoms. So we're right on the cusp of an amazing time, and it's driven almost entirely by the technology that's available to us, but also by really smart, creative scientists that are taking on this area. The average age at the Broad Institute is around 36, which is highly depressing to people like me. But
really,
yeah, but they see that this is a field where they can actually start to make a difference. You know, it's kind of it's an inflection point for biology. So, like chemistry had its periodic table and geography had its globe. You know, biology all of a sudden has its blueprint, and now it's time to actually step in and do something with it.
And there's so much going on. You know, I read Science Daily, and there's at least one genome-related article every day. It's fascinating. And also, actually, one of the things I find most interesting is talking about the benefits of personal genetic testing. Just a little.
So let me come back to my recipe comment.
Okay.
You know, it's, first of all, a lot of what's being sold out there by companies who will remain unnamed at this point is minimally useful for managing healthcare, if at all. Very few diseases can be traced to a single or even a couple changes in DNA sequence. And those tend to be the really rare and pretty horrific diseases. And if you think about it, it's obvious why those things are rare, because obviously evolution selects against those. So something like PAPEX or cystic fibrosis, those can be linked to single gene mutations or a couple, and they're very rare. Now, these companies are actually selling what are called genome-wide association markers, basically alterations in the DNA that are associated with certain diseases, and then there's multiple ones, but are not, first of all, are not the cause of the diseases. They just happen to be in the neighborhood, kind of a flag. And secondly, they don't offer a huge difference in risk. So if you have a 20% increased risk for heart attack based on your current genetic profile that these companies are selling, but your risk initially was 1%, so you're talking, 1.2%. 20% sounds really scary, but it's really kind of irrelevant. And the only action you take basically is, eat better, exercise. So, you could have gotten that information from your grandmother for a hell of a lot less.
And that's one of the issues with this, is some people are worried about having access to that kind of information. And it's not even the privacy issues, which I do want to get to later, but it's having that information about yourself. We actually we had somebody call in who actually didn't want to speak on air, so we're going to read this question. How will the world progress in the next 100 years regarding theology and genomics? Seems like a rather large question.
In theology and genomics?
Mm-hmm. I'm assuming she's talking about the intersection between.
So I'm going to, well, it's hard to insult your listeners, I'm sure. So one of the things that's actually fascinating to me is the basis for belief, and I believe there's definitely a biological basis for belief, like there is of most human traits. So why people act certain ways, some of it's environmental, the way you're raised. Some of it is you have to have some predisposition to it. So I suspect that not just genomics, but human biology studies are going to continue to push back the kind of areas where theology has always claimed prior knowledge. And we're going to begin to understand why some people are more disposed towards religious belief than others. That's not to say that we're going to try to destroy belief or theology, but ultimately theology is about things that can't be claims knowledge of things that can't be measured or tested.
Right.
Aquinas always talked about, and others talk about the via negativa. You can never say what God is. You can only say what God is not. And theology and biology is going to continue to tell them what God is not. And
that's an interesting way to put it.
I have a funny feeling that ultimately we're going to discover that tendency towards belief and the feeling of transcendence and stuff has an amazing biological basis. Does that mean there's not a God? That's a question that's beyond the ability of science to answer. But it certainly is not the God of the gaps that currently exist that kind of fills in where science has not yet.
Right.
So I have no doubt there's going to be theological studies in 100 years. I just have a feeling they're going to be hugely circumscribed by biology. They're either going to embrace that or be entirely irrelevant.
Well, again, callers, if you want to get involved in this conversation, the number is 780-492-2577, extension 1. You can also reach us at live at skepticallyspeaking.com or on Twitter at Skeptical Radio. Now, we have Scott on the line from Edmonton. Go ahead, Scott.
Hello.
Hi, Scott.
I have a question for our intrepid geneticist here.
Okay.
Hopefully, you people have seen the movie Gattaca. Or do I have to explain it?
Fintan, can you hear that?
I can barely hear it, Desiree. Would you mind repeating it? Hi, Scott. I was saying there was this movie called Gattaca, where instead of pretty much the premise is the world they live in is one where they're totally obsessed with genetic profiling. And instead of swiping ID cards, you scan your DNA, and that determines what sort of jobs you can hold. And seeing as we're progressing so much in us every day, and I don't know, everyone wants to know, is this world possible or plausible or either one?
So Scott wants to know if Gattaca is a possibility.
I'm sorry, if what is a possibility?
Gattaca, the movie. I'm sure you've been asked the Gattaca question.
Oh, yeah. And, of course, the name is very clever because, it's DNA sequence, GATA-CCA or whatever. Very cute.
Listeners, you learn something new on this show every time you listen.
Very clever, huh? Yeah. And I should know which amino acids that codes for, but I can't remember. Unlikely. It's one of the real problems that with the genetic testing as well that I didn't raise, and the kind of general public understanding is that somehow genetics is destiny, and it's just not. There's way too many other bits and pieces that are involved in it. So even identical twins are not identical ultimately. They may have the same DNA sequence, almost entirely the same DNA sequence, even though there's a bunch of weird little deletions and things that go on. But the kind of epigenomics, the things that sit on top of genetics, the modifications of the genome are vastly different between twins. It's very hard to try to engineer. It's impossible to put in a genetic program and think it's going to end up somewhere that you can control. There's just too many elements around it. It's a fun movie, and it's great escapism, but it's ultimately, if it was that easy, we'd all be geneticists.
Right. Biology is
hugely complex. It's just not simply genetic. And one of the things that does worry me a lot, and one of the things we confront a lot, is that people will get some of these tests back, for instance, or think about making, wouldn't it be great to have some gene stuck in so my kid is going to play Carnegie Hall someday. And, it's really predisposition. There's a whole bunch of other stuff that has to happen, and it's pretty random and pretty hard to control. So Gattaca simplifies it beyond belief, much like some of these genetic testing companies do.
Right.
But it's still fun, and Keanu Reeves, he's not Canadian, is he?
What? You have a thing about Canadians. Don't try and foist your trash.
No, because I was going to say he can't act, so I didn't want to insult anyone.
Thank you.
But he's fun to look at.
He is. Okay. He is. I will accept that. So a Gattaca level result is not necessarily possible, but is it the case that your genes can be held against you in some way? Because that is one of the big fears, isn't it? That insurance companies are eventually going to be able to look at your genetic indicators and determine you're not a good bet?
Well, I mean, some of that goes on. Again, coming back to, there are very few genetic predictions that are absolute.
Mm-hmm.
And so yes, there's a fear that they could use that, but it would be based on incredibly bad science. So if they say, your risk for heart attack has increased 20%, we're not going to insure you. It's not good science, because there are lots of people whose risk genetically for heart attack is 80% higher, and they never have a heart attack.
Right.
So it's not a good, genetics is not a good basis for making insurance decisions. That said, the power that it's been given by society, and to be honest, by scientists overhyping it, is behind that kind of concern more than anything. And that's hugely concerning, because I don't know how one overcomes that obstacle, especially when we continue to get the gene of the week, breathless things in the press.
Oh, yeah. But quite honestly, a lot of that is very interesting, and it's not all built on scare tactics, although some of it is.
Yeah, the fact is, every one of us, the human species has not been around very long. There's not a huge amount of shuffling that's gone on in our genome. We're not incredibly different from each other, and not different enough that we can make societal decisions based on this kind of thing.
Mm-hmm.
And around insurance or whatever, or employment. And so I think it's a real concern, but the concern is not because of what the science reveals, but because of the social understanding or misunderstanding of what the genetics is really showing.
Right, but and that's really one of the concerns, is that people are misinterpreting this kind of information. And even if the science tells us that that's not the direct way, or that's not the correct way to go, it is still possible that for example, the police could find some value in this and potentially want to set up a DNA database. And I'm totally staying with the creepier possibilities here, because that interests me.
Yeah, no, the forensics area is actually a huge area of concern, because the genetics, in terms of interpreting or predicting your future health or your future in general, it's not hugely useful. But in terms of forensics, it's really good at identification.
Mm-hmm.
And because there is enough different, when you consider there's 3.2 billion base pairs or so, and every person has kind of a unique signature in that sense, there's a lot of stuff that's not relevant to specific biology, just happens to be the detritus of evolution we're all carrying differently. That is a little creepier, and the notion that people will have that identification with them. Some of my colleagues would argue that it's no different than a unique Social Security number in the United States, for example.
But it's so much more personal than that, and that's the thing.
Well,
we very much think
still,
our genes are what makes us us in a lot of ways.
It feels more personal, but in some ways we are so much we're so much more than our DNA sequence. Where the sequence is intertwined entirely with all of our life experience and all the environmental things we've been exposed to, and but it is definitely a unique aspect of each of us, and that makes it a much more personal feeling thing.
Which is one of the reasons why it creeps people out, but not just that. Scientists in Israel recently demonstrated that it's possible to fabricate DNA evidence.
It's possible to, I'm sorry?
To fabricate DNA evidence. Did you read that article?
Yes.
It's creepy.
And frankly, I mean, it is.
Can you explain how they did that?
I'm not entirely sure. So DNA is a fairly simple molecule ultimately, and it's fairly easy to manipulate, fairly easy to reproduce. It's a tough little molecule. It's hard to destroy it, which is why we can extract DNA from mammoths and Neanderthals, and the technology is good enough that you can let the imagination run wild. I wouldn't want to give a cookbook to anyone.
Right.
But again, it's a great marker of personal identity. But if I had, for instance, Desiree, if I had your genome out in front of me, the only thing I would know for certain about you is that you're a girl, assuming you haven't had a really amazing surgeon somewhere in the back.
Well, we'll never know.
And even then, I would know that.
Right.
But
really, is that as narrow as you can get? Because what I'm reading in the news, and again, this is mainstream media, and everybody likes to be exciting, and that usually means things that scare the crap out of you. So, one of the issues is that somebody, since we are going so far in this research, that somebody could pick up a cup that I've used and possibly submit it to, let's say, a personal genomics organization and get my genomic information in their name, so they would know all sorts of information about me.
But what would they really know? They would know what kind of rare recessive mutations you might be carrying. Mm-hmm. They would know if you have any of the kind of major genetic diseases, which is highly unlikely at this point. And they would know you were female because you have 2 X chromosomes. Now, that said, as the more genomes we sequence, as we're plowing along here, the more we're going to begin to sort out what are the things that contribute to various diseases. Again, it's still going to be risk. It'll be a better measurement of risk. It's not going to be destiny. So it's not, in some ways, it's not as dangerous as having your credit card number stolen, because that's a specific number that goes
absolutely.
And so I think what happens. I want to come back to your first question. There's this notion that somehow we're hugely special as human beings.
Right.
And it gets tied into this is our genetics makes us, each of us individually, incredibly special. And from my perspective, that's not hugely different than religious belief where God cares about me personally. That makes me very special. It's just a little piece of our biology, ultimately. I'm not trying to diminish the importance of genetics.
But you're saying we're taking this aspect of it entirely too seriously.
It's what these personal genetics companies have done to it. They've taken advantage of our human narcissism and our personal belief that we're hugely special, to sell a product that makes us feel special that doesn't really tell us much about ourselves.
Next time on Skeptically Speaking, we'll be talking about Ogopogo with Kennedy Goodkey, one of the actors in the new independent movie The Beast of Bottomless Lake. We'll be discussing the history of this Canadian sea monster, what it's like to be a skeptic in the not-so-skeptical acting community, and what it's like to shoot a movie in a town where the tourism industry is built on the perpetuation of a myth. Call in and question everything on the next episode of Skeptically Speaking, every Friday at 6 p.m. Mountain Time, here on CJSR.
Hello, faithful listeners. Desiree here, host of Skeptically Speaking, the show that is the only, to the best of our knowledge, skeptical call-in talk show. The only show that interviews the experts and offers you the opportunity to get involved in the conversation. The only show that asks you to call in and question everything. And I bring this up because in a few weeks I'll be asking you to call in for another reason, to donate money. CJSR, the community radio station that allows Skeptically Speaking to use their studio and their equipment and their airwaves, is holding their annual fundraising campaign. If you listen to Skeptically Speaking and you appreciate what we're doing here, please consider donating. There aren't that many radio stations that would allow us to bring this kind of skeptical material to you. Please help us show them that this kind of programming is necessary and welcome and loved. And FundDrive also helps the station buy new equipment. And if you listen to this show regularly, you'll understand exactly how important that is. CJSR's FundDrive, September 25th to October 3rd. More information coming soon. We now return you to Skeptically Speaking. Well, audience, if you want to be special, send us an email to live@skepticallyspeaking.com. I would say use the phone, but I don't trust it. Okay, well, you know, you're talking about being special, and recently scientists were able to convert an organism into an entirely different species by performing the world's first genome transplant.
Yeah. So let's talk a little bit about what it is they actually did.
Okay.
So, in essence, it's kind of a weird version of cloning in the scientific sense. Not cloning like making multiple copies of people. We're not talking 1984 or anything like that. So some of these microbes are, first of all, they have very conserved, tight genomes, and some of them are very difficult to manipulate inside the organism itself because there's just not the tools to do it. Mm-hmm. So in essence, what they've done is just take the genome out of this particular mycoplasma, I believe, and put it into a yeast cell, made a couple changes, isolated the genome again, stuck it back in the cell, in a donor cell, and we're able to get the donor cell to live. So it's a way, it's in essence, how do I talk about this without sounding rude, but it's a weird kind of technological sex.
Okay.
Kind of, okay, let's shuffle a few genes around, see if we can get this gene to work or that gene to work. It's kind of another step beyond putting microbicide or pest-resistant genes in tomatoes, or it's nothing in a sense that evolution wouldn't do given enough time and space. So way back when before us eukaryotes arose, the ones with nucleuses and mitochondria, there was this amazing coming together of a couple organisms that had two different genomes, and they kind of worked together, and one became our mitochondria, and one became chloroplast. That it was a massive reshuffling, and it would be considered wholly unnatural if it happened in a lab, but in fact that's what evolution did. and there's regular kind of gene transfer that goes on between hosts and parasites, and other kind of weird examples from biology where genes are transported into one organism and altered, transported back. It's just we're doing this kind of in a laboratory semi-rationally, but it all of a sudden becomes synthetic life and artificial life. And it's called that simply because humans are the agent rather than, out in the woods somewhere. It's a little freaky. I have to admit, it's a little Frankenstein sounding, but it's not. There are so many environmental constraints on anything like that working that it's hard to imagine that we could somehow unleash something like the Andromeda strain.
Right, and that's obviously the concern.
Yeah, no, and it's not a bad concern. Mm-hmm. It's just that it's not a Frankenstein beast. These are kind of normal genes. They're just trying to get this thing to do slightly different things. If we try to introduce something like horrific in there, it probably wouldn't work. And now that said, there are kind of really scary biological things that can be done. You can introduce some horrible snake bite toxin into a E. coli bacteria and unleash it on a population. That's pretty straightforward. The technology for that kind of thing. Again, I'm not going to offer any cookbooks or anything.
Right. Thank you.
God knows who's listening to us, but
they're all good people. All of our listeners.
I want to go to the TAM 8 meeting, so I just don't want this to happen.
Good call. Well, this is one of the things. It's one of the things that they're trying to do with this research is to make biofuels, correct?
Or biofuels or environmental remedial agents that can clean up, next time the Exxon Valdez decides to take a tumble in some shoreline, it can be cleaned up quickly by organisms that like to live on that stuff. It's one way of doing it. And that said, too, these things are so stripped down they would never live in anything but the nice these vats that they've been grown in. But it does prove the point that the technology is good enough that one can think about making these kind of weird little organisms. I mentioned earlier the potato flight fungus. Mm-hmm. We were laughing, half seriously, half laughing about what would happen if this thing decided it had a taste for humans. That's a pretty scary thought.
You scientists are creepy. I'm going to use creepy, that word, this show, about 100 times.
Have I said creepy 100 times?
No, that's me. You can continue to use it if you'd like. I think it's a technical term at this point.
Yeah. No, another way to look at it is, there's this exuberance about life. It basically looks for niches and tries to fill them. Evolution is hugely promiscuous when it comes to here's a new possibility, and give it your best shot, folks, and things shuffle around, and life charges in. It's truly amazing to see the kind of diversity of stuff that exists out there in the weirdest climes that manage to survive and thrive. And in essence, us humans, by trying to control our environment, have, with our wonderful lights and technology and occasional phones that work, are creating environments that evolution is perfectly happy to let organisms try to tread in. And our challenge is, as human beings now, with our ability to control this, is that suddenly we've got the possibility of being kind of the handmaiden of evolution, so maybe an unwitting one. So exactly. I find that kind of creepy as well.
Well, what are some of the new things that have been done in the last little while that maybe people wouldn't have heard of? What I'm trying to do is put the focus on maybe the good things that are happening rather than they're going to steal your DNA. There's going to be a DNA bank. All of the scary things that we think about. What are some of the good things that are going on with genomic research?
So things like cancer are actually, we've had a war on cancer since since Athens and Troy, but we actually suddenly have the insight and the ability to really understand and shut it off, thanks to a lot of this stuff. So the kind of halfway house we're at right now, we really understand there are actually some good therapies for various types of cancer, but the trouble is they're only good for certain people. So now we know which people those are, and that makes a huge difference. So, for instance, there was this drug for non-small cell lung carcinoma, lung cancer, that was approved at one point, but only about 10% of the people benefited. And now we know what that is about that 10%, and that's because of the genomic studies. And so this drug is like a miracle drug for that 10% of people. So, boom. It's really clear. You carrying this genetic signature, this drug is going to cure your lung cancer.
Right.
And there's tons of examples like that are coming out of this stuff that we and others are doing. We actually have finally begun to understand the causes of schizophrenia and bipolar disease, what the genetic basis is. And now we have a real biological basis for saying, okay, here's a way to try to address this. Tons of metabolic diseases, across the spectrum, infectious diseases. This is probably where people are least aware. And here, this is a huge social issue, too, and I'll explain that in a second. So tuberculosis, malaria, and dengue fever, and all these scary buggies that are really good at getting us HIV.
Right.
Now that we really have begun to understand how not only they work, but how we respond to them, what's the host genetic load that responds to what they're bringing in, now we know here's how you shut them down. And so finding compounds that actually go in there, address the issue, don't do the side effects, basically shut the buggy down. It's actually amazing. For the next 5-10 years, we're going to see amazing things in all these areas. Now, the social issue here is a lot of those major infectious diseases are not first world diseases or developed world diseases. Sorry, I hate to use the PC term. And so we have to have the social will to develop these things as well. But it's hugely exciting. I'm like, wow, this is actually, we're going to see an end to this stuff in our lifetime. Very cool.
And that's brilliant that's the thing. In your position, and it just seems like you as a person, you very much focus on attempting to communicate the positives about genomics. So how do you deal with the fact that, the majority of articles that I read, for example, before the show, definitely had the air of potential doom in all of them? It's always as if the choices are between presenting it as like a potential ethical or biological catastrophe waiting to happen, or else not writing about it at all. So how do you deal with that?
So there's different groups when you think about this. So if you think about a patient group, that's a hugely motivated group that's very excited that this stuff is happening and make a difference for them, if not for them, for their kids. But they're facing mortality. Then there's groups that actually there's a fear underlying. Well, like I said, I can't insult folks who listen to this for sure. There's a fear under this. It's tied into somehow our specialness, the feeling of our specialness. Mm-hmm. It's tied into this notion that somehow a world order is going to change, or the traditional way of thinking about things is under assault, and as a result, it's going to be really bad for you, and XYZ. Not much different than the healthcare debate going on in our country right now.
Right.
And it's also based largely on ignorance of what this does and doesn't mean. And I find this hugely frustrating that people take that particular immediate defensive approach to it instead of seeing kind of the wonder of all of it. And there's also kind of this untranslated fear, and it's not entirely without basis, that scientists are not thinking about all these implications, or that they could care less about them.
Right.
And there are probably some scientists like that, God knows, but or goddess knows, or whatever knows. And and we don't have a great history. So, Herman Muller, who was a brilliant geneticist, was also a eugenicist. And there are days driving around Boston where I'm all in favor of eugenics rather.
But not today, correct, Fintan? Because on that note, not today, you're not in favor of eugenics, because we are out of time for the day. Thanks so much, Fintan, for being on this show. That was lovely.
Wow, that was a fast hour. That was,
it's because we have very few commercials and many technical difficulties, so it goes quick. So thanks to you.
It's my pleasure. Thank you very much.
Thank you. So if anyone out there wants to continue the discussion, we'll be over at www.skepticallyspeaking.com. And thanks to Jarrett, Mike, Ryan, and Josh for assorted show-related loveliness. And we'll see you next week on Skeptically Speaking.
South America does not exist. The moon is painted on the sky. Things sometimes fall up, but you never see. And everything you believe is a lie.
Dinosaurs were invented by God as a test. Our bodies don't rot when we die. Oh, the hippies are working for the government, and everything you believe is a lie. She wanted a girl,
and everything you believe is a lie. Everything you believe is a lie.
It's been years,
but I've never loved you,
and I never will,
though I've tried.
We'll never get married.
I'm dating your sister, and everything you believe is a lie.